So the graph does that. And those points are 2, 0, and then 0, 1, and 0, -1. So again, right now you don't have to graph that, but that's what you'll get. All right, let's do another example. Go on to an application question. Let me grab the question. So it's this one. Copy that, and we'll come back to here. So here's our next question, is application. I whited out there, blocked out the solution because it's right from my book, so I didn't want to have to use that, just so we don't know what the answer is right away. So this says an electric sign for a grocery store is in the shape of a rectangle. All right, so you're going to have to draw a rectangle. The perimeter of the sign is 72 feet, and the area is 320 feet squared. Find the length and width of the sign. It's a very typical question. Right, so draw a rectangle because it said it's a rectangle. So do a rectangle like this. And every time you have a rectangle, you know properties of it. You know that you have a length and you have a width. We know that the area of a rectangle is what? What do? You do length times width. We also know the perimeter of a rectangle, P, so all the way around it. And so you get 2L plus 2W. All right, then it tells us that the area is 72, which is L times W. And it tells us the perimeter. Oops, I did that backwards. Sorry about that. So it tells us the perimeter is 72 and the area is 320. So we say 320 is your length times your width. And then the 72 is the 2L plus 2W. And that's basically your system that you want to solve. Looking at this, I see a couple things. I see that there's a 2 in common, so I can divide that out. And then I need to solve this, so I can solve the first equation for L or W and substitute. And then you solve that. So this is a very typical type of question that we will do. So let's go ahead and divide out. And so you get 36 equal to L plus W. And then I have, from there, a couple ways to go about it. What might work best then, actually what I think works best now that I look at this better, let's solve this for one of solve 36 equal to L plus W for a variable, and then substitute into this equation, the first equation. Right, do you see that? So what did I do? I ended up solving for L. So L is 36 minus W. And then take that, 36 minus W, and substitute right here. Okay, so then you get 72. No, sorry, I don't want to use 72. Use the 36. So I don't want that one. I want this one. Right. Straight this. No, that was right. I'm sorry. That's right. So 320. So 320 is equal to L, which is 36 minus W times W. So that's the one you want to solve. And if you look at that when you distribute, you can see you'll need to use quadratic. It's going to be quadratic form. So let's write that in quadratic form so we can try to factor it. So it's W squared minus 36W plus 320 equal to 0. and then factor it, product of two binomials. And after a little bit of work, right, you come over here, do 320. So 320 is 32 times 10. It is, that's 8 times 4 times 2 times 5. And then those are all the combinations we can use. And the sum is 36. So it looks like I could do 20 times 16. Yeah, that's going to work. So it's W minus 20 and W minus 16. So you have two cases, but you'll see it's really just one case. So L is 36 minus 20, which would be 16, or L is 36 minus 16, which is 20. So it's a symmetry going on. So usually we report the length is the longer side and the width is the smaller side. So we'll say the length is 20 feet and the width is 16 feet. And that's our solution. Okay, so try this one. I have another one. Let me copy this over. And come back. So we'll do this example. This is the last example in this section. So try this example. I'll work out some of it. All right, so a closed box is in the shape of rectangular solid with height 3 meters. Its surface area is 268 meters squared. If the volume is 240 cubic meters, find the dimensions of the box. Okay, so the setup is very similar. Some of the formulas you'll want to write down is the volume is length times width times height, and the surface area. So look some of that stuff up and see if you can figure it out. And I'm going to go ahead and just show you the solution, and we'll talk about it a little bit. So I'm going to go ahead and just grab that from over here. Okay, so here's a good picture of one. Let's copy that. Okay, so that's kind of what I drew up for the picture. All right, and then here is let's just zoom in like this. This is the solution I have for it. So hopefully you worked out a lot of this. And I'm just going to show it to you, because it is something I would have definitely spent a lot of time in class having you work out. So I didn't want to spend just a bunch of time doing this again myself. Okay, so this will be in the notes, you can check this out. So we'll just kind of go through it briefly. You have your volume and your surface area, and then notice there's 3 variables. So what you need to do is solve and then substitute. Okay, it does tell you the information to help you solve it. Okay, so here's the setup. Okay, it tells you this key piece here. It tells you the volume, but it does tell you the height. That's critical. So it tells you h. So now you only have 2 variables to worry about. And then you do all your substitutions and solving, and you should get 10 and 8 meters. Okay, so I don't usually just do that, but it is something I would have given you plenty of time to work out. Okay, so if that didn't make any sense, I'd start over and try it yourself if you hadn't done so already. Okay, that should finish then. 5.4, and that's probably enough for the week. And we'll see where we're at.